So, hi everyone. Good morning. I can't hear you. Good morning, jeeconf. Great. So, this is my first time here in Kiev and I'm very excited. So, thank you for coming. And before we begin, let me see a raise of hands. How many of you have heard about event sourcing and CQRS before? Oh, that's a nice show of hands. Well, keep your hands up, please. How many of you have implemented a system using these patterns? Great. How many of you are here because you heard the words microservices, event-driven, or you just here because you don't like the other guy's talk? So I hope I will teach you something new today. My name is Lidan, and I lead the notifications team at Wix. A long time ago, I think it was 2010, I consulted to a startup that wanted to organize photos that people uploaded to Facebook. And the idea of that startup was to aggregate all the photos that were taken at the same event or location so that people can discover them easily on the social network. Now remember, it was 2010. There was no Instagram or Snapchat. One of the hardest buzzwords those days was social network. Everyone did it, at least they thought they did. And we also try to build a social graph on top of those photos that connects people, locations, events, and photos. So we started to build a network. We used MySQL as a database. We had a table for photos, a table for events and locations, and a table of relationships that connects them all. So I asked them, guys, how are you going to query that table in large scale? And they were like, we don't worry, don't know yet. I left a couple of months later, and when they started to grow, they spent thousands of dollars to maintain this unusable, super expensive structure, instead of using a better structure for this use case, like a graph database. In the long run, they didn't survive. But this story is an excellent example of accidental complexity. We model our data in some way, and when the requirements change and the model doesn't fit anymore, we worked very hard to maintain it, instead of using a better structure that is more suitable for the new requirements. And the wrong kinds of models can cause us a ridiculous amount of accidental complexity. And today, I'm going to talk about this problem, and I'll show you how event sourcing and CQRS can help you solve it. A few years later, I joined Wix as a backend developer in the CRM platform team. And Wix is an Israeli company that offers a website builder that allows you to create stunning websites effortlessly. You just drag and drop elements to your site, like building a PowerPoint presentation. And we also offer more than 300 applications that everyone can add to their website. Wix builds some of them, and you can see some examples here. And there are also third-party applications. In the CRM platform team, we build tools for SMBs, small and medium businesses, that help them to grow and manage their businesses online, such as contacts, chat, and invoices. And when I joined the team, it was the early days of the invoices project. And the idea was simple. The business owner goes to the app, issues a new invoice, and sends it to the customer. The customer receives that invoice and pays it online, for example, via PayPal. The business owner can always manage the invoices and track what was already paid, what hasn't been paid yet, and see the overdue invoices. Now, we're all developers, right? So given some markups, we know more or less 90% of the work, right? So we started to design the solution. It's a classical layered architecture. There is a REST endpoint that handles requests from the client, passes it to the business logic that does some magic, and stores it in the database through a domain model. So the user creates an invoice, he fills in the form, clicks on Save button, and then we make a past request to the server. We think really, really hard what to do. We make a decision, and we store that decision in the database. This is how a new invoice is saved. After some time, the user realized he had made a mistake. So he goes to the invoice, he edits the details, and clicks on save. Again, we think really, really hard what to do. We find the relevant record in the database and change it in place according to the user's request. And you probably noticed that when the system is designed like this, we lose data by design. It's not a security issue or a technical constraint. This is how the system is designed. And while this architecture might be perfect for some kinds of applications, mostly because of its simplicity, it cannot be used by financial applications. Why? Regulation for Wix and also for its users. By law, we have to give our users the ability to track every action that was done in their invoices. Another requirement was scalability. Wix has more than 120 million users and 5 billion requests a day. So every invoice is viewed by the users of our users, okay? So we are talking about very large numbers, and doing it right is challenging. Obviously, we can add more and more servers, but it comes with a cost. So we thought about new ways to design the system differently to satisfy these requirements, and we started researching best practices in different industries. There is one industry that is prominent in regulation and scale. Can someone guess what it is? Does anyone here think that every time he or she withdraws money from an ATM, a record in the database changes? And what's interesting for me is that it's not only the banking industry that took this approach. Every single mature industry that you look at is naturally event-sourced. Financial, medical, insurance, legal, all of them are conceptually event-sourced. And that's what naturally brought us towards looking at event sourcing for our invoice management application. Event sourcing is a way to model your data that doesn't store the current state, but rather the sequence of events that led us to this state, starting from some initial state. And we can always restore the current state by replaying the events and derive it from them. Of course, we cannot do it oppositely. In this approach, every action in our system is expressed by the domain language. And we have two basic building blocks. We have commands and events. A command is an external request that is coming to our system. It is always expressed in imperative language, like create invoice, delete invoice. It represents the user's intent to do something in our system, and it may have a payload with some relevant details. And you can see an example here. Notice how meaningful the command is compared to HTTP language, like create invoice versus post, /invoice, etc., etc. After validating the command, and we will talk about it soon, it is transformed into a chain of events. It can be one event or more that represents facts, something that happened in our system. And therefore, it is always expressed in past tense, like create invoice, invoice created, delete invoice, invoice deleted, okay? And like the command, the event may also have a payload with some details, and it is immutable. It is never changed. So let's say you are a business owner. You created an invoice and you made a mistake. Now you want to delete this invoice. So what do? You create a delete invoice command that is transformed into an invoice deleted event. But the invoice actually was not removed from the system, just marked as deleted. We are stating actions taken from the language of the business domain. These are not SQL statements like insert or select, and not functions in your favorite ORM. The language is universal among everyone involved. Whether a developer or domain expert read this sequence, they will get a full story, and they will easily understand it. After transforming the command to events, we store them in the database with a fast insert operation. And the events are the fundamental source of truth of the system. As you can see, the database doesn't hold the current state. Rather, it holds the sequence of events that led us to this state. And the benefit here is that instead of writing down our decision, we are writing down what the user wanted from us. So when a user wants to view an invoice, it's also called the current state, referred to as an aggregate in DDD, domain-driven design. We retrieve the events of that invoice from the database, and we apply them one by one, and rebuild the finalized state that is eventually returned to the user. And for those of you who are familiar with functional programming concepts, you can think about a state as a left fold of the previous behaviors. In each iteration, the event changes the current state of the aggregate, and after iterating over all the past events, we return the state to the user. So now, when we store every single action, and we are able to rebuild the entire state from those actions, our system is regulatory compliant. But more importantly, we are not losing data. And the whole system is described by the domain language and not in the language the technology forced us to use. But now we have a problem. If we only store events, how do we query them? Well, I have an idea. Let's replay every event that was ever stored in the system. This will be fast, right? So let's talk about queries, and more importantly, querying at scale. If we examine the distribution of flow between read and write operations in web-scale applications, most systems have more read operation than write operations that actually mutate the data. Around 90% are read operations. And when we design a system in large scale, we tend to bind the read and the write model, despite the fact that in most cases they're totally different. It is much easier to scale read requests of immutable data than write requests. You don't need to manage complex locking mechanisms or handle inconsistencies. And besides that, most of the time we don't need to read the data in the same form it was written in. How many of you have large, complex SQL statements like this in your application? Come on, don't be shy, we all have it. I'm looking at this query, and the only thought that comes to my mind is, what the hell is going on here? So CRUD is difficult to scale, and we have more considerations like normalizing the data to support new features in the future, like full text search or graph capabilities that are not supported by the current data store. Do you remember my story from the beginning with the graph capabilities we need? So in fact, what we need to do is to separate the process of updates and the provision of queries. And this pattern is called CQRS, which stands for Command Query Responsibility Segregation. In most of the event store systems, you usually don't query your events. You end up with a concept called read models or views. Every time a new event is written, it may also update a view. And a view is a read-optimized set of data that is used to make the reads faster. It can be a denormalized, pre-aggregated table in MySQL, but it doesn't have to be relational. Actually, it can be an index in Elasticsearch or just a flat JSON file. And it's not necessarily stored in the same database like the events. And this pattern allows us to see our data from different points of view. When a new requirement comes, we just add a new view to the system and build it by replaying the events from the beginning. So when you work in this pattern, you cannot change what happened in the past, but you can have a new perception of what happened in the past. And I'll give you an example. Here you can see our first mockups of the invoices management application. And you can see the numbers. We have a paid, sent, and overdue. And actually, it's a view. We have a table that contains the numbers. And of course, another column for tenant ID. And same from the table below. We have the same table, like the UI, in the database, and another column for tenant ID. And we don't calculate the numbers during the read. We just select from the view and return the result to the user. So it looks simple, but it introduces you new approaches to architect your systems. You can execute the read and the write model in the same service, or separate them to different services and different databases. And when you have two separate services, you can scale each of them independently. For example, you can deploy the write model in your own data center and move the read model to the cloud. But when using this pattern, you must take into account the inconsistency window between writing the events to the event store and updating the view. So you lose the strong consistency and you end up with eventual consistency. And while some applications can live with that limitations, others cannot. It depends on the business and the domain requirements. One more thing about CQRS is that you can use CQRS without doing event sourcing, although they naturally go together. For example, when you publish a Wix website, we create a new site that is highly optimized for our viewer application. And it is stored separately from the editing model. And this separation allows us to run Wix in two different segments. We have the editor segment and we have the public segment. And each segment has its own scaling policy and SLA policy. So you can do CQRS without event sourcing. Remember that CQRS is an optimization. And like every other optimization, beware of doing it prematurely. It is difficult to do it well, and it makes your system more complex. So please, 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 don't try to solve problems that are probably not existent in your system. And out of everything I will say today, this one is probably the most important. So I would suggest you consider doing CQRS when you really have scaling issues, and when the distribution of flow between read and write operation is highly asymmetrical. For example, in the invoice management application, we started by reading the raw events from the database in each request and building the views in memory. And when the applications grew and scalability started to be an issue, we changed some views to be persistent, and that improved the response time of the read model. So eventually we came up with the following design. This is the invoice management application in very, very high level. So when a user wants to send an invoice to his customer, we create a command in the client side. We have the command name and the aggregate ID, it's the invoice ID, and some payload that is relevant to this specific command. We have subject and message. And then we make a post request to a single endpoint, execute. And then the JSON object is passed to the command decoder that deserialize it and transform it from just a JSON to a JVM object. And then it is passed to the command handler. And after a validation process, the command handler is responsible for transforming the command to a chain of events. So we have the event, we store the events in the event store and return the result to the user. Can be okay, so the event was stored and everything is fine, or it can be a failure, for example, in case of a validation issue. And then we publish the event to the event bus, and we have multiple consumers on that bus. We have analytics for BI, we have emails that actually sends the email to the customer, and we have some read optimized view. For example, in the table I showed you, we have the status of the invoice. So we just update the status from draft to sent. So this is the right flow. And because this application is CQRS based, the read model is very, very simple. We just have an endpoint that receives the invoice ID, and then we go to the read optimized view. We will talk about the other arrow soon. We just compare the versions with the latest version in the event store and update the view accordingly. And then we return the view to the user. So now, by using the CQRS pattern, our system can run in large scale. And we can add new features easily by creating views. But basically, we got more than that. First, since we store every user's action, we got an audit log for free and by design. Every change in our system is logged in accurately. And because we are relying on it as a source of truth, we are more confident to use it than a regular text file. That's actually a very powerful tool. You can use this log for different purposes. For example, as a debugging tool, in order to understand what led the user to the current state. And we can also take those events and replay them in different environments, isolated from the production environment. For example, for testing purposes or experiment. And actually, we can restore the whole system to some point in time by replaying the events until that point. If you want to know how an aggregate looked like a few weeks ago, we can just do it. We have the event stream. And we can not only restore the data, but we can analyze historical data that would be lost if we didn't use event sourcing as our data model. For instance, whenever you come up with a new idea or new algorithm to analyze your data, you can just update the event handler and replay the events from the beginning. And this is a very powerful tool. And trust me, your BI analyst will thank you for that. Another interesting feature is the ability to create different schemas according to the system requirements. The event stream is the single source of truth, and views are derived from it. Think about it. At any point in time, I can blow away my views completely and rebuild them from the events. This ability makes it easier for everyone in your company to consume the event stream and build his own view of the world. So I'm looking at you, and you probably think, silver bullets, too good to be true. So I'm going to tell you a secret. Event sourcing and CQRS are not magical solutions for your system. As you probably know, choices of architecture are never good versus bad. It's just a trade-off at some context. And you must take into account the complexities of every solution you choose. Some challenges are raised only when you work on a large application with real business and real traffic. And those challenges can appear in two different forms. Number one, the development model is unusual, especially when you separate the read and the write models. It feels strange at the beginning. There is a learning curve, but it's not that hard to get used to it. But let me ask you a question. What do you prefer? A very thin layer that handles commands and events, or a large, complex SQL schema that restricts the queries you can run? Now, after separating the read and the write models, you can work with different data stores for various models. Well, how do you manage them? How do you do backups? What about monitoring? So during the development of Wix invoices and some other Wix products that used our internal event sourcing infrastructure to manage the data, we encountered three major challenges. How do you keep your views in a consistent state? Does your application has to be fully consistent, or can you be settled for eventually consistent? And eventual consistency means the data doesn't have to be consistent all the time. The only guarantee is that data becomes consistent at some point in time, eventually. And for most applications, eventual consistency is sufficient, but there is no single solution for that. It's always a trade-off between consistency and performance. So first of all, we can build a fully consistent system by replaying the events and building the views in memory in every read request with no persistence. And the disadvantage of this approach is the strong binding between the read and the write model, which makes it harder to scale each part of the system separately, especially with complex views. So we can do it better. And another possible solution is synchronous writes. You don't have to use a heavyweight distributed bus like Kafka in order to update your views. You can just do it synchronously. And in this approach, we have all the benefits of denormalized, read-optimized views, but the writes will be slower since we need to update multiple views. So we can do it better. And a better solution might be comparing the current version of the view with the latest version of the event store. And if there is a gap between them, we update the view and return it to the user. So these are the main three ways to handle view inconsistency. And of course, it is tunable. You can choose the consistency level per each view. You can also mix the methods. For example, you can update the view asynchronously during the read flow, and also check the versions in the read flow like a self-healing mechanism. Okay? And consistency is a product concern, not technology. Okay? This is a very important point. And most of the teams don't do this conversation with the product managers. They just choose the consistency level by themselves. So I'm really sorry, guys, but it's not our decision. Just ask a product manager, the business expert, and they will know better than us. The next topic is validations. How do you validate the commands in your system? And we have multiple levels for validations. For example, you can validate the payload data, string length, numbers range. And in Wix, we use Accord for this kind of validation. Accord is an open source Scala-based library that allows you to validate input data with a very, very simple DSL. And you can see an example here. So this is the first stage of the validation process. And we can also verify that a given command can be performed on the current state of some domain entity. For example, the application cannot handle update command if the aggregate was already deleted. And for this case, we mark these special commands, create and delete, for example, with Scala trait. Scala trait is like a Java interface. And before handling the command, we check its type with the current version of the event store, and we can store an exception. We can throw an exception. What about more complex validation? For instance, let's talk about uniqueness. Imagine you're developing a contact management system. How can you make sure that there is only one contact per tenant with a given email? And a possible solution for this case is creating a special view, persistent view, for this validation. And on the validation phase, before transforming the command to events, we check if the given email already exists. And if it does, we throw an exception. And I know, some of you probably noticed that validations that are based on view may raise inconsistency problems, and you're basically right. Again, it depends on the business domain and the business and the domain requirements. Some systems can live with this inconsistency once in a million writes, for example, but others cannot. And you should take this point into account when designing a system that is based on this pattern. The last thing I want to talk about is concurrent writes. Let's assume that two commands were written at the same time: update invoice and delete invoice. What will be the state of that invoice eventually? So one solution is to use pessimistic locking. So only one command per aggregate can be handled at the same time. So once the first command takes the lock, any other command will wait for the lock to be released. This is the safest way to prevent concurrency issues, but obviously it's the most complex and slowest. We need to manage distributed lock, handle timeouts, yuck. So we can do it better. And let's talk about optimistic locking or versioning. So each event of an aggregate has a version that is incremented by 1 every time a new event is written. The version of the aggregate is the version of its last event. And in this solution, the command has the expected aggregate version. It is the version that the aggregate was when the command was issued. And in case of a gap between the expected version and the current version of the aggregate, we will throw an exception. We can also resolve the conflict by merging events. For example, here we have two versions with the same, two events with the same version, but different type. So here we can just increment the version by 1 and merge the events of the aggregate. And when it's impossible to merge, for example, when you have two events with the same version and same type, we'll throw an exception. And you can guess that also here, the way you handle concurrent writes is based on your business requirements, not on the technology. In a context management application, we can probably merge events. We have, I don't know, the email event and the name event or things like that. And in invoice management and accounting are more sensitive domains. And merging events may change the invoice completely. So we've talked about event sourcing in CQRS, and we've seen how to design a system using these patterns, and we've discussed some issues that may be raised. So what have we learned at Wix in the last 3 years from using these patterns? First of all, start small. Don't try to model every entity in your system using events. That's a really bad idea. So before you go back and say, Lidan said we should event source every entity in our system, and we should separate reads and writes, ask yourself the following question. Do you really have a benefit by storing the history of those actions? Is it worth the operational cost, or can you remain with CRUD? I'll give you an example. In the invoice management application, we have a feature of tax presets. It's a tax name and tax rate, and it's a preset. You can just use it to create invoices faster. Is this feature worth the cost of modeling it with events? What will be the view look like? A table with a tenant ID, tax name, and tax rate? So CRUD sounds like a better idea. in this case, although the rest of the system is all event sourced. Code changes. Once an event of some type was written to the database, you can't remove its definition from your code base. It's also harder to change it, add or remove fields, and you should always think about backwards compatibility. Remember, once events are written to the database, they will be there forever, and your code should know how to handle them, even when you deprecate or stop writing them. The last and most important point, in my opinion, is that the events are the single source of truth of the system. And you can always delete the views and reconstruct them by replaying the events. And this ability gives you a lot of power. You can build the user interface incrementally. You don't have to normalize your data or write complex queries or run data migration scripts. Just remove the view and rebuild it from the events. So I hope I convinced you that it's worth researching more. And here are some references that might be helpful for you. And here are some JVM libraries that allow you to build event sourcing and CQRS applications. And we are working on open sourcing our internal event sourcing library. Hopefully, we will release it soon. But forget about all those. The new kid on the block is Kafka Streams. And I strongly recommend you to come to Amitai's talk tomorrow about building event-sourced application with Kafka Streams. Is really, really cool. So to summarize, event sourcing is a pattern that allows us to capture our user's intent by writing down the whole story of what the user does in your system. And this pattern goes naturally with another pattern, CQRS, that gives you the power to evolve your business logic incrementally by using views. And by separating read and write operations, it allows you to solve scaling issues that may be raised when your systems grow. However, like every other architecture, there are some trade-offs that you must take into account when working this way. And we've talked about how to validate commands and how to handle views consistency or inconsistency, and how to handle concurrent writes. So in conclusion, if we go back when we started the Invoices project, none of us had an idea of what an event sourcing or CQRS are. We knew the concepts, but we had no idea how to implement them or what are the challenges we're going to face. Since then, we've implemented and migrated multiple services in weeks to use event sourcing and CQRS. It absolutely changed the way I think about data. Keep it in your event store. Thank you very much. So I will be here for questions, but before we move on to the question and you go to break, I'd like to hear what you thought about the presentation and if you have any feedback. So if you'd like the slides, you don't need to use your camera. Just go to this URL now, escqrs.online, answer a very short survey. It will take you 30 seconds. I promise 30 seconds. Push submit, and you'll be taken to the slides. And I'm also available in Twitter, so feel free to contact me if you have any question. And again, thank you very much.